Now what I'd like to move into is what I just call growth and development of corn. And understanding this will go a long ways towards just managing that corn crop, especially as it relates to yield. I think one of the best books available for looking at corn growth and development is a book produced by Iowa State. This is the latest version down here, this yellow copy. And the reason I like it so much is because it breaks down the development of corn and the management options available into basically one season. The yellow version, the most recent version here, also has all of the references that are used for many of the recommendations in there. And I think that is also a good thing to have in your library. So what we're going to do today is learn the Iowa State system for staging corn, but know that there are a number of different ways of staging a corn plant. In fact, if you count them all up, one time I did this, and there are over 20 different systems out there. The National Corn Insurance, Crop Insurance Association system has their own system for staging a corn plant. Instead of counting leaf collars, they count the angle of the leaf. Each pesticide label has their own system where some labels count all the leaves you can see. Some of the labels skip the first leaf. Again, just a lot of different ways to do that. And finally, there's one called the BBHC system. I've seen more activity recently on this, but it's an attempt to kind of unify the staging of all crops into one system, and maybe this will be replaced down the road. I haven't seen it. We've heard about this for 20 years. I haven't seen it yet, so it might be a little while yet before we see it. But today what we're going to do is learn the Iowa State system for staging a corn plant. And the Iowa system is relatively easy. It's basically broken down into two types of stages, the vegetative stages and the reproductive stages. The first stage starts with emergence, so as soon as you can see that corn plant come out of the ground, that would be the VE stage. And then the next stage would be when you can see the first leaf collar. And then the second leaf collar would be V2, V3 is the third leaf collar. And this can continue on all the way up to about V15 for hybrids in the northern part of the state, and V23 or so, or 21 for hybrids in the southern part of the state. That's typically how many leaves a corn plant will produce. The last vegetative stage is a tasseling stage, or VT, and then about 2 days later, the plant transitions into the reproductive stages. And that is basically a 60-day period divided into about 10-day increments, going from R1 to R6, and they are silking, blister, milk, dough, dent, and maturity. So what we're going to do here today is we're going to kind of work through a hybrid that's about 95 to 105 days relative maturity, planted May 1 in southern Wisconsin. And we're going to use that as an example to look at not only how you stage a corn plant in a corn field, but also some of the management options that are available and what the plant is doing at these different stages. The first thing we got to do is define what is a leaf collar. And the leaf collar is basically where the leaf blade transitions to the sheath, which wraps around the stalk, and then that sheath is actually attached to the plant at the node. But that transition area between the blade and the sheath is called a collar, and you can see that collar on this plant right about here. Basically, you count that as an emerged collar when you can see it on the plant. In other words, you don't have to pull back the leaves or anything, but you can just see it, and it's usually a line that's kind of on the plant there. So you count that basically as an emerged plant. The other thing that's kind of diagnostic for corn, especially early in development, is that the first leaf of corn is typically rounded. All the other leaves are going to be very pointed. Okay, but this first leaf is a very rounded leaf, and that's, again, diagnostic for corn as a plant emerges. Eventually, though, the plant gets so big that first leaf dies and basically gets torn off the plant. And then we use something that the hail adjusters use a lot, and that is they slice the plant lengthwise, and then they look at the bottom part of the plant here, and the first 4 nodes are all compressed on top of one another. And then the fifth node is just a little bit above those bottom four, and you can see this inner node in here as well too. But remember, the leaf blade transitions to the collar and then the sheath, and then the sheath is attached at these nodes right here. So just by pulling back the leaves, you can then pull back and see once where that leaf blade is attached to via its node. And again, the first four nodes are compressed. The first one that you can see is the fifth node, and then you can just kind of count backwards a little bit and then see once what stage that particular plant is. And this is typically about V6 or V7 is when that first leaf is pretty much died and is being sloughed off the plant. And at that point, you need to start slicing plants to be able to stage the plant correctly. So in this case here, what is the stage for this particular corn plant? I'll give you a little second here to kind of orientate it, but if you were going to stage this plant, what stage would it be using the Iowa system? You can see that this first leaf down here is kind of rounded, so we know that that is the first leaf. And so this would be the second leaf. The third leaf is here, the fourth, the fifth leaf. And then you can just barely see this line right here where the collar is on this sixth leaf. So when you see that sixth leaf, we would stage then this plant as a V6 plant, okay, using the Iowa system because we can see that leaf collar. Now, the hail adjusters would probably stage this as a V5 plant because this plant is starting to point down. The leaf is starting to point past horizontal. And that would be a V5 plant in the hail adjuster system. Some herbicide labels will have you count all the leaves. So you can count V6, V6, 7, 8, and 9. You can see 9 leaves on this plant. And so some labels will call this a V9 plant. Some labels will have you skip this first leaf. So on those labels, this would be a V8 plant. And you can see the confusion that kind of comes into this. But I think the industry is kind of transitioning into this Iowa system of just counting the leaf collars. And I think that's a good one to learn at this point. So this is a V6 plant using the Iowa system. Okay, so that's a way to stage a plant. Now what about staging a field? Because not every plant in that field is going to be at the same stage. So here we've got a field that had about 30% of the plants at V4, 30% of the plants at V5, and 40% of the plants at V6. What would be the stage of this field? Okay, basically you would stage the field for whatever stage that those plants are at with 50% or more. So in this example here, 40% of the plants are at V6, so the field is not quite at V6, but 70% of the plants are at V5 or beyond. So that means this field would be at the V5 stage of development and getting pretty close to being at V6. All right, so that's how you'd stage a field if you're out doing scouting or working with growers in that way. Now, one of the things that we use in agronomy and entomologists use, weed scientists use, everyone uses that grows crops is some sort of a benchmark or clock, if you will, for kind of calculating how corn grows and develops. And farmers have a lot of different sayings that they use to kind of schedule various operations, if you will, during the growing season. One of the common ones, of course, is knee-high by the 4th of July. But we know in Wisconsin that if we're knee-high by the 4th of July, we're way behind in terms of our development. And that used to be a very common saying, but it's kind of gone out of favor lately. But these are some of the sayings that are out there. Some of them are kind of humorous, but those are ones that are oftentimes used. What we use nowadays, though, is something called growing degree units. And this is where you take the maximum temperature during the day and the minimum temperature, divide them by 2, and then subtract some base temperature. Now, corn will typically grow between 50 and 86 degrees Fahrenheit. Now, once it gets beyond those temperatures, And that's pretty comfortable for you and I as well too. But once it gets beyond those temperatures, it gets uncomfortable for the corn plant, and that corn plant starts to slow down its growth and development. So what we basically do then is we use these maximum min temperatures during the day. The upper limit's 86, the lower limit's 50, and then we use a base temperature of 50 degrees Fahrenheit, so that for any one day we can accumulate, based on the temperature during the day, anywhere from 0 to 36 GDUs. Now if it was 0, the maximum would be something below 50, and the minimum would be something around 50 or so. So 50 divided by 2 minus 50, 50 plus 50 minus 2 divided by 2 minus 50 is basically 0. Likewise, 86 would be 86 plus 86 divided by 2 would be 86 minus 50, and that gives you this 36 GDUs for the maximum that you can accumulate. If you're at 90, say, for a day, you would only use 86 as that upper limit in these calculations. All right. Now we use this for corn and soybeans, and then we also use it for other insects and pests to kind of gauge when they're going to start emerging from the winter, or when they start to emerge and go through various parts of their life cycle. And these are just some examples here of different insects. The stalk borer, a minimum is used, 41 is used to predict migration, for example. And again, these are very common things that are used to kind of set the clock, if you will, for corn growth or for growth and development, what's going on during the season. Now, if you look at a growing season, what we see is that during May, we're only accumulating about 10 GDUs per day. So if we plant our corn crop on May 1st, we're accumulating GDUs at about 10 per day. And so by May 11th, we've accumulated about 100 GDUs on that clock. Okay, as we get into the summertime, we'll typically, on average, accumulate up to about 23 GDUs per day. And then as we get into fall, it cools back down. But when you accumulate all these GDUs during the growing season, we typically, for southern Wisconsin, accumulate about 2,600 GDUs during that growing season. So we've got to pick corn hybrid maturities that are something less than 2,600 GDUs. This gives you kind of a range of when that corn plant goes through various stages. Again, to get emergence, it takes about 125 GDUs to get emergence. And so if we're only accumulating 10 a day, we plant on May 1, that means we're going to, on average, emerge about 12 days later, and the range is about May 10th to the 14th. We typically will achieve V6 at about 470 or so GDUs, and that will typically occur about June 7th to the 9th. Now, knee high is about V10 to V12, and again, on average, we should be at that V10 to V12 stage by about June 26th. And typically a leaf will come out about every 2 to 3 days during the growing season at this time. So that corn plant should be pretty tall, probably belt high to chest high by the 4th of July. We typically go through silking, or the reproductive stages, beginning about the 15th of July or so, July 17th here. And then we're typically mature by about September 11th or so. And again, this is our typical clock, if you will, and our typical growth and development of corn during the season. But of course, we'll have years that are going to be cooler or warmer, and that development is going to be adjusted as the season goes on. One of the major decisions that growers are faced with almost immediately is the maturity that they picked for their corn hybrids that they grow on their fields. In the northern corn belt, we're challenged by growing season. As you move south, growers down there enjoy a lot longer growing season than we do in the northern tier of states in the U.S. In the southern part of the state here, we'll typically grow about 110 to 115 day relative maturity hybrid, and that requires about 2,700 to 2,900 GDUs to complete that life cycle. In the north, we'll typically grow about an 80-day hybrid, and we only get about 1,700 to 2,000 GDUs in the northern part of the state. And this makes all the difference in the world. And the way the corn plant adjusts is it adjusts as it moves north in the state by producing fewer leaves on the plant. So in the southern part of the state, we'll produce 21 to 23 leaves. In the northern part of the state, we'll only be producing about 15 leaves on the plant. So if there's fewer leaves to come out, it doesn't need to go through as much of its life cycle during the vegetative stage, and you end up with shorter plants and fewer leaves. Okay, so let's just go through this emergence a little bit and some of these, what I just call key stages in the life of the corn plant. Of course, one of the key ones is the emergence stage. If you don't get that seed out of the ground and get that plant going, you're not going to have plants growing out there for later yield and kernel development. The first structure that emerges out of the seed is something called the acrospire or coleoptile. If you put your finger on the tip of that coleoptile, it's very hard, very pointed, until it sees the soil surface. Then there's a light reaction that occurs that softens the tip and allows that first leaf to come out of the tip of that coleoptile. Now, oftentimes one of the things that we'll see is unfurling underground, and we usually will see this when we have crusting that occurs from a hard rain, or we might get some frosting that occurs, or some sort of cloddy soils, and oftentimes this coleoptile sees the light, so to speak, softens, but then we get crusting that occurs, and then the leaf basically then unfurls underneath that crust on the ground, and it's basically searching for a crack or something in the soil to basically emerge and get out, and oftentimes it can't. And that's one of the, we'll usually lose oftentimes 5% of our plants or so just due to this type of a condition. So as that plant's emerging, you see the radicle come out first, then we see the coleoptile start to emerge. You start to see seminal roots growing by about that V1 stage or so, and shortly thereafter, and right here's a plant that's basically at the V2 stage, you see some roots growing right here, right where that growing point is sitting. These are called nodal roots. So we've got the radicle, the seminal roots, and the nodal roots all growing and developing by the time the plant's at that V1 to V2 stage of development. Now the seminal roots and the radicle are going to be the ones that are going to take up all the starter fertilizer. The nodal roots become the dominant root system of the plant, and they'll grow 3 feet to the side and 5 to 7 feet down into the ground. These radicle and seminal roots only last about 3 weeks or so, and then they die back, and the nodal roots become the dominant root system. Now, there's a fourth root system that occurs as well too, and that occurs later on, and it doesn't emerge till about V12 or so, V12 to V14, and these are called brace roots, and they're a scavenger system that basically scavenge nutrients and water and resources from the upper layer of the soil later on in the season. If we were to dissect this plant out right here and look at it, you can see all the different kind of plant parts that are there. Here's the V1 leaf. It's got that rounded edge on that first collar. Here's V2, V3, V4, 5, 6, 7, and 8. So we've got 8 leaves that we can see when we dissect this out, but this would only be a V2 type of a plant. The other thing I want to point out is this structure right here. This is the growing point. And at the V2 stage of development, that growing point is sitting about 3/4 of an inch to an inch below the soil surface. Now this is really important because in the northern tier of states, we oftentimes have a number of frosts that come through and basically burn off leaves that have emerged on corn. But since that growing point sits below the soil surface, there's a little bit of an insulation effect that goes on that allows that growing point to survive. If that growing point was above ground, then we would have issues with plant death and things, and that happened in 1992, what we call the Father's Day frost, where many plants were at the V6 to V8 stage of development, and the plants, in other words, the growing point was above ground, And the plants at that time basically all died because the growing point was frosted and died. But at this stage, it's below ground, and it's relatively protected from some of these low temperatures. There are other things that can get it, but a cool temperature doesn't necessarily hurt corn because that growing point is below ground. So by the time the plant has got the V2 stage, you can see a lot of the different plant parts present. You see the coleoptile, which stops at the soil surface, the leaves and the whorl of the leaf, the nodal roots that have grown, the radical and seminal roots, and then there's this structure right here called the mesocotyl, which attaches the seed piece to where that growing point is growing right here, about 3/4 of an inch below the soil surface. This mesocotyl is important for planting depth, and I'll show that right here. If you plant corn, generally I recommend planting corn 1.5 to 2 inches deep. But many times growers like in Kansas or other places will plant corn to moisture. And so sometimes they'll plant that corn seed 3 inches or more in depth. Many times farmers will find seed laying on the surface. And in Wisconsin, it's not so much of a big deal, but as you go west, where you have a lot of dry conditions, you can have something called floppy corn syndrome. Roots will not grow in the dry soil. So these seminal roots and nodal roots, if that seed piece is laying right on the soil surface and it dries out, those roots will not develop. And what it'll do then, the plant will just basically flop around on this mesocotyl structure until moisture occurs, and those roots then grow into that soil profile a little bit. But the growing point of corn always develops at 3/4 of an inch below the soil surface. So if you'd plant this seed 3 inches deep, or 4, or 5, or I've even planted it sometimes 10 inches deep, this growing point still grows at about 3/4 of an inch below the soil surface. And what happens is this mesocotyl extends and pushes that growing point to this position in the field. Now at 10 inches deep, you don't get a lot of plants survive, but this mesocotyl is about 9 inches long when that occurs. And again, it's one of the characteristics for corn, and it all has to relate to where that plant can germinate and imbibe water and get the process going, and that's how the corn plant handles it. But this mesocotyl allows you to be able to plant to a lot of different depths in corn, and that growing point's always going to grow about an inch below the soil surface. Okay, so that's what's happening early. Now, by the time the plant hits or gets the V6 stage or has 6 leaf collars on the plant, you can see there's basically all the parts are there on the plant. The ear hasn't quite developed, but the cell primordia, that's just the start of that ear, is already starting to develop on some of these within some of these leaf tissues here. I ask you, what is this structure right here? This structure is located right here on the plant, and it's right at the very top of where the leaves are developing. What would this structure be? It looks like an ear, right? But it's actually the tassel. Okay, and the tassel is the last structure to form on the plant. And about the V5, V6 stage, it forms, and at that point, it starts to grow up and move above ground. Now, if we get a frost at this point, basically what will happen is you kill the plant and you kill the growing point on that plant because it's now above ground. And this usually occurs about June 7th to 10th or so, is when this, on a May 1 planting date, is as to when this structure starts to move above ground. But the important thing here is that you can see all the plant parts are there. The nodal roots are very large. And again, by this stage, they're halfway between the rows. They're 15 inches to the side, and they're growing 3 to 4 feet down into the ground. And if we get a drought at this time, it's not a big deal. Flooding, on the other hand, can be a very big problem because anything that's highly respiring is going to require oxygen, and flooding is going to prevent that oxygen from getting to those actively growing parts of the plant. Things like the growing point and leaf tissue and that sort of, and roots especially. Usually about this time you'll start to see, or shortly after, you'll start to see something called suckers developing or tillers. Um, Generally, if you see tillers, it's kind of an indication to the plant or to you that the plant was probably planted in at too low of a population for that hybrid in this field this year. And so one of the things I always encourage growers to do is to maybe correct the next year by increasing 1,000 or 2,000 plants per acre to basically get that hybrid or that field kind of set up for the right population. We know that the optimum population for corn has been increasing about 500 plants per acre per year. So that means you should be growing about 5,000 more plants per acre today than you were 10 years ago. And again, if you see a lot of these tillers form, that's usually an indication that the plant population was probably too low in that particular year. Now, the other thing too is that you'll oftentimes see a lot of branching occurring in cool, wet seasons. And so when you have a year that's cool and wet, that's also an indication that the plant is probably going to put on a lot of these suckers. And we don't know really whether it's good or bad for the plant to do this, but most of the tillering phenomenon within corn has been bred out by breeders. Now, it hasn't been bred out in barley and wheat, and we still rely on tillering in some of the other small grains that are grown. All right, so the plant continues to develop. V12 is another kind of key stage, actually about V10 to V12, because at this time, this structure is developing right here. Now, this structure is the ear. Okay, and this is, if you look at and dissect out that plant, you can see all the leaves that are there, all the roots, and now the growing point is this tassel, which is sitting right up here, but then you see all of these structures right here. Okay, these are what are called ear shoots. Okay, and usually the topmost ear shoot becomes the dominant ear, and that's the one that's expressed and eventually grows into kernels and grain and that sort of thing. The others are there and they're present, but they oftentimes aren't expressed because of this dominant one that's grown at the highest position. But again, a corn plant will oftentimes produce, 8 ear shoots on the plant, and that's very typical for corn in Wisconsin. About this time, we start to see brace roots emerging. Again, this is kind of a scavenger system. Sometimes we'll have years where we'll have real high winds come through in July, or the early part of July especially, before these brace roots are formed. And oftentimes there's a lot of lodging that can occur without these brace roots out there. I don't get too worried about it because the plants will tend to snake back up, but obviously having brace roots out will help that plant stay upright, and you don't have that snaking going on right above the soil surface with that stalk. Okay, now the plant usually about V18, and then depending on the hybrid, you can have 21 to 23 leaves or so before that tassel comes out. But right about this time, the plant is really getting prepared to go through a very important phase in its life cycle, and this is a reproductive phase. Basically what happens is the tassel comes out, pollen starts to drop from the anthers that are on that pollen. Usually that pollen only travels about 50 feet from the plant, but to isolate cornfields, it requires 660 feet isolation. But at this point, we're starting to see pollen drop off of those tassels, and usually the pollen will start to drop about 2 to 3 days before the silks start to emerge on the plant. And again, this is a very important stage, I think, for management, because it's something that's very easily seen from the road, and this timing of when this occurs can dictate some of the decisions that you make later on. For example, if you see tasseling late, you might want to consider that field for silage production. Okay, if you see that tasseling occurring when there's a stress going on, then you really have to watch your success of pollination later on. And again, if it's not very successful, you might need to consider that field for silage harvest later on as well too. But again, if things progress well, normally it shouldn't be any big issue or anything. But again, note that tasseling date, because that'll oftentimes dictate what happens during the reproductive stage. You can also use it to time things like custom operators that might come and cut corn silage, because the reproductive stage is very similar regardless of the maturities. Remember, maturities were adjusted for shorter season hybrids by producing fewer leaves. But in the reproductive stage, whether you have a 80-day hybrid or a 110-day hybrid, the reproductive stage is about 55 to 60 days, regardless of the maturity of that hybrid. And we can use that to our advantage if we know when that tassel date, or actually the silking date, occurs. But knowing the tassel date is a good thing to know in terms of management later. Okay, then shortly after then, silking occurs. Silks that emerge are first from the middle part of the year, then the butt, then the tip, and then the butt and the tip. And basically, pollen lands on these silks. They germinate. It takes a lot of water. They grow down the length of those silks, and then fertilize the ovule, where that kernel will eventually grow. All that happens within the first 7 to 10 days during that time is cell division within the ovule. After 7 to 10 days, the cell division stops, and then those cells get filled by photosynthate from primarily the leaf just below where the ear is at. About 60% of your yield comes from this leaf alone, and then from other leaves up and down that stalk. But this leaf is a key leaf and provides most of the yield for that corn grain as it develops later on. So this is a very critical stage, and we oftentimes talk about this in terms of what we call the nick. Usually pollen drops for about 8 to 9 days, and silks emerge for about 7 to 8 days. And what you want to have is as much overlap of pollen drop and silk emergence as you can, so that you can get every kernel possible fertilized on that particular year. When there's stress out there, especially drought stress, oftentimes vegetative development speeds up, silk emergence slows down, so instead of a nick of 7 to 8 days, your nick may only be 2 or 3 days, and this is when you start to get into a lot of pollination issues, especially during those drought years. Again, you'll have about 8 ear shoots develop on that plant. This shows a plant that has had its leaves stripped away, and you can see the individual ear shoots there, and the dominant ear, of course, is the uppermost ear shoot on the plant. The kernels then go through various stages: blister, milk, dough, dent, and then physiological maturity. And you can see some of those stages right here. The final stage, though, is a black layer stage, where a 1 cell layer thick group of cells basically suberizes or forms a corky layer that prevents any nutrients moving from the ear into that kernel. And once that occurs, the kernel is done growing. And by just taking some of those kernels off the ear and kind of using your fingernail to scrape it away, you can see when those black layers form on individual kernels. And again, typically the middle of the ear will mature first, and then move towards the bud and the tip of the ear later on. Now, if there's one thing I want you to know about silage, and that's this slide here, in that if you look at quality as estimated by milk per ton, you can see we have very good quality right around that flowering stage of development. Late flowering stage, just like alfalfa. Very good quality right at that particular stage of development. And like alfalfa, that quality, as measured by milk per ton, goes downhill very quickly as maturity goes on. But unlike alfalfa will continue to go down. Unlike alfalfa, corn silage quality goes up as that grain starts to come on. And we end up with better quality at maturity than we do back at the flowering stage. And this is important to know this characteristic here, because what we of course want to be doing is harvesting corn silage back out in here somewhere. But many times we'll have to plant corn late, or we get in a drought situation and probably have to harvest some corn back in here. If you look at overall milk per acre, which is the economics side of corn silage production, we're at our best milk per acre as we get closer to maturity. So again, we can use this as we try to manage corn and corn silage and make decisions once harvest time comes as to which fields might be good candidates for grain or for silage. Again, this last stage is the black layer stage. I mentioned before that the first 7 to 10 days of this grain filling period is just cell division. After that, we increase grain yields about 4 bushels per acre per day. It's about a 40-day period where there's a linear increase in grain yield. And then the last 10 days or so, it kind of levels off and basically goes through a maturing and dry down process the last 10 days after about R5.5 or so. But grain can be harvested once that black layer forms. It's not going to get any more grain yield. All that requires there is a physical dry down of that grain down to about 13 to 15% moisture so that you can store it long term. Okay, so there's still some GDUs that need to be accumulated because we need to use those to dry the crop down to get the moisture down, but the crop is pretty much mature and can really be harvested any time once that black layer forms. Now, there's a lot of factors that affect corn growth and development. These are a few of these. Most of these are primarily during those early phases of planting and the early part of the season. We do have stresses that occur in season, and oftentimes we really don't know how the plant is going to react oftentimes when those in-season stresses occur. And there's a lot of hybrid differences as well too. But we can adjust that clock a little bit, those GDUs a little bit, with some of these typical adjustments that have been documented in the literature in the past. Okay, just to kind of wrap this up again a little bit, once you get to this harvest stage then, we know that forage moisture is going down at this time, and milk per ton has this kind of this S-shaped pattern here a little bit. Milk per acre is going up in this fashion here. We're at our best quality and also best yields once we hit that R5 to R6 stage or so for corn silage. The real driver, though, is that moisture and the moisture for the storage structure. Grain yield, it follows kind of this S-shaped curve again. Right in here, you're putting on about, at a 200 bushel yield level, about 4 to 5 bushels per acre per day. And then it kind of slows down as you get towards maturity. This first part of this is just all cell division on this first part here. And then, of course, grain moisture is down in here. One of the things that we can do here from a management perspective is, let's say we have a custom chopper show up at our door and that forage moisture is too wet. It's back up in here. Well, one of the driest parts of the plant at this stage in development is the grain. So by raising the cutter bar, you can adjust that moisture to get it in sync for the storage structure that you've got. So let's say you're putting it into a conventional silage and it's or a conventional silo, and it's way too wet. It's at 65 to 70% moisture. Well, the guy shows up at your door. One way to adjust that a little bit, especially if you don't need all the yield, is raise that cutter bar a little bit. The wettest part of the plant is left in the field, and you're harvesting the grain, which is the driest part, and that should bring down your overall moisture as you try to fill that silo. So as you look at this curve, then it all kind of comes back to this R1 stage, and if you have good success for pollination, then you can really harvest anytime, or if it's poor, you can really harvest anytime because you don't have any grain development. If it's fair, then you would leave that for silage harvest, and you'd probably be harvesting it back out in here. If it's good pollination, then you have normal management, whether you take it for silage or grain or whatever you're going to take it for. Generally, silage can be harvested here as well as over here. Now we see a lot of shredlage coming into play in Wisconsin dairies. If you let it go a little bit longer, and once that grain moisture comes down a little bit, you can also harvest it for high moisture corn, earlage, toplage, snaplage, and then later on as well, you can harvest it for dry grain as well as bottomlage out in this part of the year. And we're seeing a lot of guys taking and harvesting a lot of that stover and using it for bedding in many of these dairies in Wisconsin. Okay, so with that kind of gives you then a sense of the growth and development, some of the key management timing things that need to go on. What I'm going to do now is I'm going to just stop and take a little break, and what I'd like to do is from here on out is just talk about the yield components of corn and when is yield determined during this life cycle of corn.